due until the Sunday at the end of spring break, but you should definitely get around to doing it beforehand, because if you can understand the homework, you'll do fine on the quiz tomorrow. Yes. Not anymore. I didn't purposely put any more on it than I would have otherwise. It's just, it doesn't hurt me to give you the extra time, so might as well. All right, so here's the big change between today and the last, or I guess for you guys it would have only been on Monday. What are we gonna see today that we didn't see on Monday? Because, yeah, we're gonna see an equal sign, and because we see an equal sign, now we need to solve for the variable. Okay? These equations are gonna be just like the expressions that we dealt with, and that they're quadratic. I'll try to save myself 5 minutes by not asking you what quadratic is again. That was a complete disaster the last time. I think it's the teacher's fault. And we're still going to solve by factoring. So especially if you went back and watched the video and stuff and you have a good understanding with factoring, that's the big burden today. That's what the quiz is going to focus on tomorrow. So if you notice, step 2 is what tells you to factor. So here in step 2 is what we're doing, what we did on Monday. The extra stuff that we're adding in today, because we have an equal sign at the beginning, we want to set the equal sign, set the equation equal to 0, which in layman's terms means put all the terms on one side. We talked about terms last time because the amount of terms is what predicated the type of factoring. Oh, the board is this way. Then once we factor, once we have individual factors, we want to set each factor equal to 0. Specifically the ones that have variables, because variables are what we solve for. And then finally, that's at the end what we do. We're going to solve. If you understood Monday, you'll do great today. If you did not, if you're going to be confused with something, it should not be steps 1, 3, and 4. If you're going to be confused with something, it's step 2. But step 2 is what we did on Monday. Well, then luckily Papa Romero takes care of you and he puts the video of the exact same thing he taught online. Okay, then I guess you're not going to do very well tomorrow. He said that he has a lot of respect for Esperanza. Alright, so here you go. Let's go to the first equation. What does the first step say to do? Set equation equal to 0. Make sure all the terms are on one side. An equation has 2 sides. Make sure that one side has nothing and one side has everything. Well, guess what? That was already done for us. Okay, so what does step 2 say to do? Factor. Let's look at the side that has all the terms, which basically means go in your time machine back to Monday, Dario. And it's almost like pretend that wasn't there, and let's just factor the side that has all the terms. How many terms do we have here? 2. What do we look for first with 2 terms? GCF. Okay, so do those 2 terms have a greatest common factor? What is the greatest common factor of those 2 terms? Not just 2. I agree that 2 is going to be part of the greatest common factor, but it's not the only common factor. What else do those 2 terms have in common? They also have an x. So I'm going to factor out of 2x. I told you very explicitly that greatest common factor is the opposite of distributive property. So like, let's undistribute this. M of B, EGB. 2x times what gives you 6x squared?
3x.
3x. 2x times what gives you 4x?
2.
Normally, I would look inside the parentheses and see if the parentheses can be factored any further, but it can't. It's not quadratic. There's a positive in there. It's not a difference. So we're done with the factoring. If this would have been on Monday, your entire problem would have looked like that. The only difference today is that we have this equals 0 at the end. So because this is equal to something I need to solve, I am now done factoring. What does step 3 say to do? Set each factor equal to 0. Normally, a factor is what's inside of a parentheses, but really a factor is every number that you're multiplying. The thing is, since the purpose of step 3 is in order to do step 4, which is to solve, and since I solve for a variable, anything that's being multiplied that has a variable needs to be made equal to 0. Long story short, in many instances, we can ignore what's on the outside, but since the outside here has an x, I need to make that equal to 0. In reality, I don't even care about the 2. You can ignore the 2 if you want, but I feel like if I do, I'm going to confuse you. So I would just tell you, okay, that's a factor, cool. So say 2x equals 0, but then also say 3x plus 2. And now solve each one. Quadratic equations can have more than one solution. They cannot have more than 2. The maximum amount of solutions we can have is 2. They usually will have 2, but they could also have 1, and they could also have no solution. Resuelva. Here. What do you mean, like to get rid of the parentheses? Well, okay, so what he's saying is, Mr. Romero, why don't I just get rid of the parentheses by distributing? Yeah, why would? But if I did that, what would happen? Yeah, I go back to where I started. I don't want that. Like the whole purpose of factoring is to go backwards from simplifying. It's the opposite of simplifying. So now let's just solve each one. Here, divide by 2, x equals 0. Here, minus 2 minus 2. 3x is equal to negative 2 divided by 3. X is negative 2 over 3. And now I'm done. I said that a quadratic equation can have more than one solution. It does. If this is as far as you go, then that's fine. But just so that you know, when an equation has more than one solution, you might see a solution set. Do not confuse this with an ordered pair. This has nothing to do with x comma y. There is no order. It's just saying x. Now instead of an equal sign, you put a colon. The elephant ear looking things that are braces, and then the order doesn't matter as long as you write both numbers. So you can put 0 comma negative 2 over 3, negative 2 over 3 comma 0. That's just another way of saying there's more than one solution. There can only be one Xavier, but there's more than one solution. What's wrong with Emma today? Did you bore her, Elsie? Did you bore her? Are you feeling better today, Elsie? Good. It's because you're hydrating. No questions there? All right, so let's move on. Yes. ¿El qué? Pidio Valdez. I don't know what that is. No. This is an equation. Here's my equal sign. How many terms do I have in my entire equation?
3.
I have 3, but what does the first step say to do?
Move all factors equal to 0.
So, yeah, basically to move all the terms to one side. Now, if you look at this, well, how many sides does an equation have? 2. So you could say, well, geez, what side do I move everything to? Do I move them all to the left? Do I move them all to the right? Sometimes you will have to go left. Sometimes you will have to go right. What should determine the direction that you go is the square. You want the number in front of the square, what we normally call a, the number in front of the square. We want it to end up being positive. Right now, what is it currently? What currently is in front of? It's a positive 1. If I were to move this x squared to the right, what would it become? Yeah, I don't want that. It's going to make factoring basically impossible. So we're going to leave the x squared and the 18 on the left, not because there's more of them, but because the square is positive, and I'm going to bring the 9x to the left by subtracting it. We started with 3 terms. We still have 3 terms. None of those terms are like, so I'm not going to combine them. But even though I'm not combining anything, it is extremely important to write it in standard form. So x squared would come first. Don't write the 18 next. Write the negative 9x and then the plus 18. I now have this equal to 0. What does the next step say to do? What does the next step say to do? To factor. Factor means just, hey, go in your time machine, pretend this was Monday, and on Monday, your problem would have looked like this. So just factor that. If you decided to move all the terms to one side, let's factor the side that has all the terms. If you understood it Monday, you should understand it today, especially if you've been doing your homework since then. If you didn't understand it Monday, yeah, it's going to be a drag. And then at the end, we stick an equal 0 at the end. How many terms are there? With 3 terms, what do we look for first? So with an a of 1, a b of negative 9, and a c of 18, do those 3 numbers have a common factor? No. But you also need to look at the variables, Rosalind. Do all 3 terms have an x? No, so there is no greatest common factor. Could this possibly be a perfect square trinomial? It's the next factoring. Well, that's one of the things we learned on Mondays, something called the perfect square trinomial, where the first and last terms would have to be positive. Are they positive? Yes. The first and last terms would have to be perfect. They have to be perfect squares. That's not true. 18 is not a perfect square. If you're not sure, take the square root of 18 on the calculator. One of the things that amazes me is that, I mean, look, I think you should have your perfect squares memorized, but even if you don't, I just told you what to do on a calculator if you need to know if a number is a perfect square. But a lot of kids don't even know where their square root button is on the calculator. They think that this is the square root button. That's not the square root button. It's that one. El raíz. Yeah, exactly. Exactly. So, if you take the square root of 18 on a calculator, it's going to give you a decimal. Any number that you get a decimal is not a perfect square. So, the only thing we can do is the evil factor chart, and then like in another period, I had people that were clamoring for the X method and stuff. I'm not against it. If you feel the X method is better, do it. I just think this is more methodical. Same method that Taiwan uses to go to sleep almost every day. Well, this is the method we use for factoring. What I would do is first multiply a times c. What is a times c? It is 18. B is negative 9. All my work is going to happen on the left side. Really, I mean, I've even thought about making this instead of, a 2-column table, just to make it 1 column even. Because that's really where the majority of our work is going to occur. I told you that I think the biggest reason people struggle with factoring is because they don't know their times tables. This is where that comes in. Are you able to tell me every pair of numbers that I could multiply to get 18? And I would think some of you could even do it in your head. I don't have a problem with that. Look, 1 and 18, 2 and 9, and 3 and 6. But now, in addition to that, to help you, Papa Romero came in over the top and says, hey, look, you take care of the multiplying, I'll take care of the signs for you. So I gave you a table that says that when the left column is positive and the right column is negative, how do I adjust my factors? Make them both negative. Go back and make negative, 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 negative. And then check and see, do any of those combinations add up to negative 9?
Yes.
Negative 6 and negative 3. Be so happy, be even more happy, because A is 1. So when A is 1, I can just go straight to factored form and say x minus 3, x minus 6. It doesn't matter the order, you put the x minus 6 first. This is an exact repeat of what we did on Monday. The only new thing today is equal 0. It's better than getting it left. You're being hurtful today, Emma. Not only did you just crawl out of bed, you crawled out of the wrong side of the bed.
I did. Crawling out of the wrong side of bed all week.
Imagine how cranky you're going to be on Friday when you wake up and you're like, oh man, I can't even go to school today. All right, so now that I factored, what does step 3 say to do? Because these are the extras to the equation. We didn't have this the other day.
Set each factor.
Make each factor equal to 0. Each factor is the x minus 3. That's equals 0. X minus 6 equals 0. Solve each one, and then you celebrate. You can dance, you can do cartwheels. Play basketball. Yeah. So as a solution set, I could put 3, 6, 6, 3, whatever, bro. I mean, I guess most of the time you see solution sets in numerical order, but they don't have to be in order. There are 2 numbers that make the original equation true, and that's 3 and 6. Fax machine. No. Hope will get mad. We don't want to make Hope mad. He's wearing combat boots, so. Never anger a person in combat boots. Why does it keep on? Stop it. All right, here's another equation. Jocelyn, you have worried face. No me gusta worried face. What does the first step say to do? No, what does the first step say to do? No.
Put all equations equal to 0.
Make the equation equal to 0. Put all the terms on one side. That's already done for you. Notice how this equation is already equal to 0. So step 1, Chekaruski is already done. Now what does step 2 say to do? Factor, which is what we did on Monday. Let's look at the side that has all the terms and decide if it can be factored. Well, you're single. 6. Do all the terms have a common factor? They do not. But could this possibly be a perfect square trinomial? Yes, it could. Are the first and last term positive?
Yeah.
Yeah. Are the first and last term perfect?
No.
Yes, they are.
No.
Well, 1 is a perfect square. 1 times 1 is 1. But forget about the 1. Look at the x squared. What times itself gives you x squared? X. X times x is x squared. What times itself gives you 25? 5. Okay? But that in itself is not enough to make sure that you have a perfect square trinomial. There is one more check. I wrote this formula for you on Monday as a courtesy. I'll write it for you again. In order to be a perfect square trinomial, b squared would have to be equal to 4ac. But that's only if the first and last 2 terms are positive and perfect. Which in this case, Okay? That's a formula to make sure I have a perfect square trinomial. But first, I have to see the reason why I did not try that on this last one. I didn't even bother to try is because even though the first and last term were positive, 18 is not a perfect square, so there's no need to waste my time. Now, there's other good news. Let's say that you have a limited capacity. You're like, hey, brain is full, no more space, no thank you. My memory is full. I have to buy a bigger memory card. If you choose to completely bypass this, you can still get the right answer by doing a factor chart, what I just did. Okay, but this could save you some time. So negative 10 squared, because that's b, would have to equal 4 times 1 times 25. What's negative 10 times negative 10? Negative 10 is negative 100. You're just keeping it 100. And then 4 times 1 times 25 is also. Yay! I have now verified that I have a perfect square trinomial. And I'll tweet it. So now I can factor by formula. Yeah, you got to remember the formula, but every perfect square trinomial will be one parentheses. Instead of a second parentheses, you put a square. That's what's there instead of the second parentheses. You keep the sign in the middle. That middle term that we ignored, but we need it for the sign. It is going to be negative. And then what did you tell me?
X minus 5.
Very good. You got to take the square roots. Like the square is being taken care of by the square out there. The x times x is x squared. 5 times 5 is 20 fizzle.
Can you just do x minus 5x?
Didn't I just say that they would work with the table? But then what starts looking silly is that, see, like, yeah, if you would have done the table, you would have gotten what Elsie said, which would have been x minus 5, x minus 5. But then people go, oh, x minus 5 equals 0, x minus 5 equals 0, and they solve it twice. It's going to give you the same answer. It's not like it's going to give you one answer on the left side of the screen and a different answer on the right side of the screen. It's going to give you the same thing. So, but yes, it would work. So because, look, if this would have been Monday, we'd be done now. But now we have an equation, so I make it equal to 0. How many, third step says make each factor equal to 0. How many factors do I have? I do have 2, believe it or not. We just saw the 2. Elsie just has the 2, but it's the same factor. So you don't have to solve it twice. You only have to solve it once. Most quadratic equations will have 2 solutions, but this one's only going to have 1. Because I only have 1 solution, I do not need a solution set. The only number that makes this equation true on the top is 5. Fax machine. Huh? The what? How did I get rid of the square? Well, I didn't show it because I gave you a step that says just to make each factor equal to 0. I only have 1 unique factor here, so I just made it equal to 0. But if you must know, if you need mathematical proof that no, there we go. That the square cancels, okay. Take the square root of each side. What does a square root do to a square? It cancels it. What's the square root of 0? Still 0. So you don't need the square. Yup, that's what they call me. Interesting. Okay, here's another one. First step. No. Make it equal to 0. How many terms does this entire equation have? It has 3. All 3 terms have to be on the same side, but I want them to end up on a side where the lead coefficient, the number out in front of the square, needs to end up being positive. If I were to move everything to the right, that would end up being negative. I don't want that. So I'm going to start off by doing minus 32 on both sides. That will cancel out. So I get x squared minus 4x minus 32. Make sure you write it in standard form from biggest exponent to smallest exponent. Now I jump in my time machine, speed it up to 88, and go back to 2 days ago. Uh-oh.
Oh, ew. Where'd they go? Oh my God, you liquid.
Okay, just go to the bathroom. We don't want sharing any bodily fluids. Just go. No, don't take the pass. Just go. Just. Ew. Hope has it. All right. So let's go through our gauntlet of factoring. Do those three terms have a greatest common factor? No. Like, look, when A is 1, you're not gonna have a greatest common factor. Could this possibly be a perfect square trinomial?
No. Yeah.
No, and I got two reasons. I only need one reason, but I have two reasons. One is that the 32 is negative. It can't be. The other one is that 32 is not a perfect square. So no need to waste my time daddy with that formula. I need to do a factor chart. The one that you were just asking me about. ¿Dónde viene ese 4? So let's do a table. What is 1 times negative 32? So that's the number I'm going to figure out what I can multiply to get. And then negative 4. So 1 and 32, 2 and 16, 3 no, 4 yes, and that's it. We have to adjust our signs accordingly. Papa Romero says that when both columns are negative, what do I do to the factors? Cassandra? You don't understand what I gave you a table where I said when the AC column is negative and the B is negative, how do I adjust the signs of those numbers? It was like a little table on the second page. Small positives, the smaller one is positive, and the bigger one becomes negative. And then ask yourself, do any of these add up to negative 4? The positive 4 and negative 8. Because A was 1, that saves us some extra work. I can now just go straight to factor form. Say x plus 4, say x minus 8. But then don't forget, this is an equation, so it's equal to 0. Very common mistakes, and I still think it has more to do with attention than with math, is that now once this gets introduced, when we go back to just factoring, when there's no equal sign, people like to just throw in an equal sign when there was never there one to begin with. The only reason I'm putting an equal sign is because it was already there. This is an equation. So now that I finished factoring, what does the third step say to do? Make each factor equal to 0. Say x plus 4 can be 0. What you're utilizing here is something called zero product property. This is the reason why this works, right? Watch. If x is presently an unknown number, I have not solved for x. I don't know what x is, right? So here I have a number I don't know. Here I have a number I don't know. The reason why I want to make it equal to 0 is because even if I don't know the numbers, if I multiply any two numbers and I end up with 0, what has to be true about the numbers? Well, they don't have to both be equal to 0, but one of them has to be 0. I could say, hey, give me a number, 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 give me a number. All of you guys give me your favorite number. I multiply them all together, and then if I come in at the end with multiply by 0, boom. You would end up with a 0, yeah. That's the whole purpose of making the equation equal to 0 at the beginning. Because if there was any other number on the side, I just showed you how for any given number, you can come up with a bunch of different ways to multiply to get it. But if that number on the other side is 0, one of them has to be 0. So we're just accounting for all the different ways. So x could be -4. Yeah, well, it helps to focus. Well, you were testing, right?
Sí.
I know, muy importante. Well, just for this one time, sacrifica and then go and watch the video. Invite Inoshka over to watch it. You can Romero flicks and chill. Que van a fajar, para fajarse para darle la mano a...
Dale la mano y dale.
Let's actually do the time constraints. Let's skip this one. And let's go to this one here. So we're skipping one and going to this one. Soha, you're interrupting his rest. How dare you? That's not nice. What does the first step say to do? Yeah, and that's already done for you. So the heavy lifting here is, do you know how to factor that expression?
Yeah.
How many? You can't?
You can't try to come back.
Well, there's no greatest common factor. Yeah. Could that possibly be a perfect square trinomial? No, 2 is not perfect. 6 is not perfect. And the 6 is negative. So, caca.
Mierda.
No, that's not nice. Darío knows all the bad words. He doesn't know both ways. Like Darío. He says that he has a lot of respect for Esperanza. All right, so what is 2 times -6? -12, and then -1. So all the numbers I can multiply to get 12 are 1 and 12, 2 and 6, 3 and 4. For the second time today. Yes.
Sorry.
Small positive. Are you focused on my stuff or are you doing like flashcards or something? No, don't. No, focus on me. I need attention. Which one do any of these add up to -1? Now the reason why I skipped ahead to this one and I wanted to make sure that we did this, Taiwan, is because we only did a couple of these on Monday. When A is not 1, you can't just do like what we did on the last ones and say P plus 3 and P minus 4. Because they're not equivalent. This does not give you that. But then I showed you kind of a watered down thing that for years I had an internal struggle with as to like, should I do it, should I not? But then I finally crossed the bridge. Because this is not a formal way of factoring, but it works. It's supposed to be easier. This is kind of my version of the X method, which is okay. Because that A is 2, get that 2 and write it in the front of the P's. But wait, there's more. You can't leave it like that. Okay? You have to go to each factor and see if they can be factored anymore, if there's a common factor. Can 2p and 3 be divided by the same number? No, so you drop it down. Can 2p and minus 4 be divided by the same number? By 2, so you have to go ahead and do so. So the 2p plus 3 just drops as if it was hot. And this becomes p minus 2. Now I'm done. When you miss these later, don't complain and say they're too hard. Because you could divide by 2. That's what I'm going to do next. Okay. So now I'm finished factoring all this nonsense that I've been working with here. This was step 2. This was factoring. That could have very well been something on Monday. I could have showed up with this as one of the problems, except like with no minus 0, and you should have been able to do it. But now because of that equals 0, is someone scaring you, Xavier? Do you need my protection? You still haven't learned how to talk to girls? It's okay. One day you'll build up the courage, man. I believe in you. Deep down inside, you're a good guy, so she'll see that. So now that I finished factoring, make each factor equal to 0. Minus 3 minus 3. Divide by 2. This one here, they couldn't be divided. So. Yeah, correct. So if you were to write this as a solution set, it'd be the little colon. So just because he looks like that doesn't mean you gotta be mean to him, okay? It's negative 3 over 2. This one here is so simple that it causes a lot of mistakes. People overthink this. So let's just follow the steps. Yeah. Negative 3 over 2 and 2. What does the first step say to do? Yeah, so when I see a lot of people, oh wait, I don't know what to do. Oh, what? Let me divide by x. No. Make it equal to 0. Shh, Xavier. Shh. I need the number in front of the square to end up positive. So if I were to move everything that way, like you're trying to intimidate the girls out with the hoodie. You notice how when you had your head down, it didn't bother you, right? But like when you're disrupting my class, it is gonna bother me. Maybe we can find a way to get you an ISS on the last day. Make it instead of a 6-day vacation, a 7-day vacation. Well, school days. So this is the first battle you gotta overcome. Take the hoodie off. Appreciate it. No, a little more. Come on, you can do it. I know. But still. I want to see your ears. You have really nice looking ears. Yeah, well, it is, but it doesn't mean it's not true. It's nice, man. It's nice. You should think about being an ear model.
What?
Yeah, like an earring as you can wear the bling. All right, so once you make it equal to 0, here's where I was telling you the overthinking happens. Darío, aquí. Yeah. Here's where the overthinking occurs. Do these two terms have a greatest common factor?
No.
Yes, they do.
No.
Yes, they do.
No.
Not just one. They both have an x. Now, even though this is a difference on the inside, this is not a difference of squares, so I'm done factoring. If this would have been on Monday, the entire problem would have looked like that. But now because of the equal 0, I have to make each factor equal to 0. A lot of times I can ignore what's on the outside, but since what's on the outside is an x, yes, that has to be one of the things equal to 0. And then 2x minus 3 equals 0. I'm done on the left. There's nothing else. X equals 0 is one of my solutions. The other one ends up being 3/2. Kind of makes you want to dance. I'm going to jump around a little bit and see if I can find, I'm looking for a specific type. Here we go. This towards the end. Skip ahead to that one. It'll be towards the end. It's towards the end. Yeah. For the what? Where do you see that? I mean the exponents by itself. I don't understand what you mean by that. I mean, if you find one, let me see. That wouldn't work, but okay, watch. All right, here. You don't have to write this down. This is more goes out to Jason, right? So I'm gonna. What he was saying is, can't we make this look like this, where 16x squared is equal to -1? Well, I wouldn't want to do that because that would mess things up. But can we compromise and say that 16x squared is equal to 1? But even if it's this problem, okay? The only difference would be that you would have to do -1 and -1 to bring it over to the left, and then that's what you would end up with. Everything has to go to one side. You have to end up with equal 0. Okay? So, now again, you didn't have to write that. The fact is we need to end up here. Now, once we end up here, how many terms do we have on the left side? 2. So we can still look for GCF first, but do we have a greatest common factor? No. What's the only other method we know for, no, not a table thingy, not with 2 terms. Say it better. No. I wish I would have written it down for you on the notes. Printed them before. No, it would be on the last notes. No, this was on Monday's notes. Cassandra? No, that's for 3 terms, not for 2 terms. But it's close though, they're in the same family. When in Rome. No, I'm not done yet. Shit! Yes? Difference of squares. If I have a difference of squares, I could factor. If not, there's still stuff that we could do, but just factoring is not going to work as a method for solving the equation. We'll learn that other stuff when we come back from break. But luckily, I do have a difference of squares. What does difference mean in math? Subtract, I have that. Here, there's no special test. It's just, do I have 2 perfect squares? What times itself gives you 16x squared? What times itself gives you 16x squared? 4x. What times itself gives you 1? You know something? 1. And then I didn't have a chance to see you on Tuesday, yesterday. But if you remember, I told you that later on I was going to ask you about this word. What does a difference of squares look like in factored form? And I wrote it down for you. I said, hey, this word is going to come up again. Conjugates, very good. I do not know why we're packing up yet. If you don't want to write this stuff down, keep it quiet, but some people still do. I could even get one more example then. That's it. I'm done factoring. The factoring is done. Now I just got to solve. 4x plus 1 equals 0. 4x minus 1 equals 0. Minus 1 minus 1. 4x equals negative 1. Divide by 4. X is negative 1 over 4. Plus 1 plus 1. 4x equals 1. Divide by 4. X equals 1 over 4. What do you notice about these two solutions? Well, the sign is different, so when they write a solution set, again, look, I'm going to give you multiple choice, so even if you didn't learn how to write a solution set, you can get away with it, but I'm just like, what you very well could see is they would just write the 1 over 4 one time, but then put a plus or minus in front of it. And I can do one more. Huh? A little bit more what? Oh, there's not much else to see. I'm just showing you, like, the whole purpose of this square is just to demonstrate to you that I have a difference of squares. But if you went from here to here, that's fine. I can live with it. It's not a big deal. You're lo mismo. Okay, here we go. Let's do this one. It's right. It should be right before it. First step. First step. First step. First step. Make it equal to 0. Minus 6y minus 6y. Shush. 9y squared plus 12y minus 12 equals 0. Okay. Do I have a greatest common factor? Yes, I do. They can all be divided by 3. So 3y squared plus 4y minus 4 equals 0. Okay, this is not a perfect square trinomial, so I have to do a chart. A would be 3, B would be 4, C would be negative 4. So negative 12 and positive 4. This is 1 and 12, 2 and 6, 3 and 4. When the left column is negative and the right column is positive, what do you do with your factors? Small negative, big positive. So the one I want is negative 2 and 6, but A wasn't 1. So I got to put that 3 in front. So I have the 3 GCF 3y minus 2, and 3y plus 6. The 3 outside automatically drops. The 3y minus 2, I can't divide anything, so it drops. But this can be divided by 3. So I get 3y minus 2, and then y plus 2. Now, when I make each factor equal to 0, this 3 on the outside is a factor, but it doesn't have a variable, so you can ignore it. So it's just 3y minus 2 equals 0, y plus 2 equals 0. Solve each one. Alright, this will be on the video.
Good.